Okay, this lecture is on right triangles. In other words, how do we make right triangles and how do we use them to solve physics problems? When we talk about physics and we talk about mathematics, we do need algebra, but then we also need to use vector algebra. That's a big word, and basically it's the mathematics of right triangles. So if you get a chance, please review that in Chapter 3 of your textbook. The hypotenuse of a right triangle is the opposite side to the angle. Notice here is your right angle. The legs of the triangle are perpendicular to one another and form that 90-degree angle. So when we do physics problems and we're working with vector quantities that are neither parallel nor perpendicular, or even if they are perpendicular, then we need to consider using these two basic ideas, which is Pythagorean theorem and trigonometric functions. So for Pythagorean theorem, we're going to use a squared plus b squared equals c squared. And for your trigonometric functions, you're going to use sine theta, cosine theta, and tangent theta. So let's talk about Pythagorean theorem first. We have c squared, where c is the hypotenuse, is equal to a squared plus b squared. A and b are the legs of the triangle that form the right angle. It doesn't matter which side you call A and which side you call B. So let's go ahead and do an example. The legs of a right triangle are 7 and 3. What is the length of the hypotenuse? Go ahead and pause the video now and solve the problem. Okay, so let's go ahead and take a look at the solution. We know that C is equal to the square root of a squared plus b squared. If we substitute in the two sides of the triangle, we end up with c is equal to the square root of 7.0 squared plus 3.0 squared. That gives us an answer of 7.6. If you had any trouble with this, just leave me a note in Edmodo. Okay, the legs of a right triangle are 2.0 and 12. What is the length of the hypotenuse? Go ahead and pause the video now. Okay, so let's go ahead and take a look at the solution. We know the legs of the triangle are 12 and 2. So we're going to use our formula again, that the hypotenuse is equal to a squared plus b squared. We take the square root of both sides. If we substitute in our numbers, we end up with 2.0 squared plus 12 squared, and then we take the square root of the whole thing. So your answer is 12.2. Now, remember I told you about significant digits? That means that this answer really should be 12, because if you look at the numbers, you're looking at the precision when you add the 12 squared plus the 2 squared. So you're really looking at, actually, no, I think that will be 3 sig figs. That's right, because the 12 times 12 is 144, and that's 3 sig figs. Actually, no, that has to be 2 sig figs. Sorry, yep, it is 2 sig figs. So the answer is going to be 12, not 12.2. Don't worry so much about that right now. Okay, I think that you have the idea here. But here they give you a different format. The hypotenuse of the right triangle has a length of 4.0 and one of its legs is 2.5. What is the length of the other leg? If you feel that you need to go ahead and solve this one to get some more practice, go ahead and do that. If not, go ahead and play it through and continue the video. Okay, I'm not going to show the work for this one. You're still going to use c squared equals a squared plus b squared. But instead of solving for c, you're going to solve for a or b. And that means you should end up with c squared minus either a squared or b squared. And then you take the square root of that. So let's check the answer. You should have gotten 3.1 for that other side. Again, if you need to practice, You have a hypotenuse that has a right triangle length of 9.0. The length of one of the sides is 4.5. What is the length of the other side? Go ahead and pause the video now or just keep playing through. Okay, so let's take a look at your answer. Hopefully you got 7.8 as your answer. Okay, so now we have a triangle and we want to look at what the hypotenuse is. Okay, if you need more time, go ahead and pause the video. If not, here's your answer. It should be 8.1. What is the length of the third side? Okay, if you need more time, pause the video. You should have gotten 25. That was actually a 3, 4, 5 triangle. Okay, take a look at this one. Solve for the third side. Okay, let's take a look at the answer. It's 5.7. What is the length of the third side? If you need more time, go ahead and pause the video. The answer is 12. What is the length of the third side? If you need more time, pause the video. Hopefully you knew that it was a 3, 4, 5 triangle. Okay, so a 3, 4, 5 triangle is the most famous of the triplets. Integer solutions of the Pythagorean theorem, that's what you end up with. You don't even need a calculator to recognize the sides are in this ratio. What is the length of the third side? Hopefully you got 10. Again, remember, this is a 3, 4, 5 triangle. If you divide all three of these numbers by 2, you end up with 3, 4, and 5. So all you had to do was recognize that 6 and 8 followed that relationship, and then just multiply 5 by 2. Okay, what about this one here? We have 12, 20. What will this side be? Hopefully you said 16. If you take 4 times 4, you get 16. Okay, so now let's look at the trigonometric ratios. We know sine, cosine, and tangent. The angles are usually called theta. So you usually see sine theta, cosine theta, and tangent theta. These ratios depend on which angle you are calling theta. It is never a right angle, though. So see this angle here? You're never going to use this one to calculate sine and cosine and tangent. You know that the side opposite to the right angle is called the hypotenuse. So this is the right angle. The opposite side of that is called, is called the hypotenuse, which is right here. Okay. The leg that is next to the angle theta is called the adjacent side, and the angle on that's opposite to that is actually just called the opposite side. Okay, there are two different angles that can be called theta. You can call this angle theta or this angle theta. So depending on which one you choose depends on whether this is your adjacent side or this is your adjacent side. Notice that if I chose this as my angle theta, the adjacent side is going to be the x-axis, and the opposite side will be the y-axis. If I choose this as my angle, what's the opposite side? It's the x piece. And what's the adjacent side? It's the y piece. So you have to be careful about which angle you're being given as to whether you have sine theta being associated with the x or the y component of your vector quantity. Okay, so hopefully you remember your trig functions. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. I believe it's SOHCAHTOA. Just, there you go. Okay, so here we have three sides of the triangle, and we want to solve for sine theta. Go ahead and pause your video now to solve for sine theta. Okay, so let's take a look at the answer. Hopefully you got 0.94. Notice here they don't want you to solve for theta. They wanted you to solve for sine theta. So how would we do that? Well, you take the opposite side, which is 8, and you divide that by the hypotenuse, which is 8.5. And that gives you 0.94. Okay, now we want the cosine of the angle theta. Go ahead and pause the video now. Okay, so let's take a look at the answer. The answer is 0.35. So how did we get that? Well, cosine is adjacent over the hypotenuse. And so that's going to be 3 divided by 8.5, which gives us 0.35. Okay, how about the tan theta? How do we calculate tangent theta? Go ahead and pause the video. Okay, so let's take a look at the answer. The answer is 2.7. Notice that we want to keep the same number of digits that we start with. And again, tangent would be opposite, 8, divided by opposite over adjacent. So that would be 8 divided by 3. Okay, what about this one? Okay, so let's take a look at the answer. Hopefully you chose 2. It's 14 divided by 7. Okay, what's the sine theta of this triangle? It's 0.88. Okay, let's do the cosine of the angle theta. Hopefully you ended up with 0.44. Okay, if you have the sides of the triangle, then you can find the angles. If you have the side and an angle, then you can find the other two sides. So that's all we're doing, is either taking the angle and the hypotenuse and finding the sides, A and B, or we're taking A and B and solving for the angle and the hypotenuse. Okay, so for instance, let's find the side X right here. The opposite, the side we're looking for is opposite to the given angle, so we can use the sine of theta. So the sine of 30 degrees is equal to x over 7. Okay? So sine of theta is opposite over hypotenuse. The opposite side is equal to the hypotenuse times sine theta. Substituting in our numbers, we end up with 3.5. Don't forget to put your calculator in degree mode and not radian mode. Okay, now let's find the side here when given the angle and the hypotenuse. Here, notice x is the adjacent side, so we're going to use the cosine of theta. So cosine theta is equal to adjacent over hypotenuse. Okay, so here we have cosine theta is equal to adjacent over hypotenuse. Multiplying both sides by hypotenuse to solve for the adjacent side, we end up with x is equal to 9 times the cosine of 25. That ends up giving us an answer of 8.2. Okay, now let's just say that we have one of the sides, we have an angle, and we want the other side. If we don't have the hypotenuse, then we can use tangent theta. And here we have opposite x over adjacent, which is 9, is equal to the tangent of 50 degrees. Okay, so solving tan theta for the opposite side, We substitute into the formula and we end up with x being equal to 10.8. Okay, so let's practice this. Here we have a triangle. We want to solve for x. Go ahead and pause the video now. Okay, so here's the deal. We want the adjacent side, we have the opposite side. That tells me we're going to use tangent theta. So tan of 64 degrees is equal to 35 divided by x. So then we can solve for x. And you should have gotten 17.1. Okay, so here let's solve for x. Okay, if you need more time, pause the video. We have the angle theta, we have the opposite side and the hypotenuse. Opposite over hypotenuse is going to be sine theta. So we're going to use the sine of 36 degrees is equal to 28 divided by x. And we'll solve for x. You should have gotten 47.6. Okay, here's another triangle and we want the side x. Go ahead and pause the video now. Okay, if you look at this, we're given an angle, and look, we have the adjacent and the opposite side. So we're going to use tangent theta to solve for x. And so you should have ended up getting 19.5. Okay, look at this one and solve for x. If you need more time, go ahead and pause the video. Here we're given the adjacent side and we're given the hypotenuse. How do I know it's the hypotenuse? Because here's my right angle. The opposite side of the right angle is always the hypotenuse. Okay, so I have adjacent over hypotenuse. That's the cosine of theta. You should have ended up with 5.9 for x. Okay, that's the end of this lecture on using sine, cosine, tangent, and Pythagorean theorem. Later on, I'll go ahead and give you some more detailed notes on how to solve the problems with vector algebra.